So again, we're using the same two triangles and the same values that we did in our first video, but now we're going to try and find the sine of alpha minus beta. So if you want to know how we got these triangles from this information here, go back and watch the first video and it will refresh your memory on how we got all of the values and the locations for our triangles. So we're going to use these triangles to try and help us find the sine of alpha minus beta. So if you recall, the sine of alpha minus beta, its formula is the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. So now we can just go through and find each of these values using our triangles and plug them in. So the sine of alpha, so this is alpha, is the opposite over the hypotenuse. So it's 5 over 13 times the cosine of beta. Cosine of beta is 2 rad 5 over 5. So 2 rad 5 over 5 minus the cosine of alpha, that's 12 over 13, times the sine of beta, that's going to be negative rad 5 over 5. So negative rad 5 over 5. Take these products. So 5 times 2 rad 5, that's 10 rad 5 divided by 65. And then negative 12 times a negative 5 is going to be positive 12 rad 5. Sorry, rad 5, not 5. And then all over 65. These have a common denominator, so we can take their sum. So 10 rad 5 plus 12 rad 5 gives us 22 rad 5 all over 65. And this can't reduce, so this would be the value of the sine of alpha minus beta. So let's take a look at one more value, try and calculate one more value using these triangles. So we want to try and calculate the tangent of alpha minus beta. Again, we're using these triangles, the same conditions, everything that we had from our first few examples. So the tangent of alpha minus beta, that's the tangent of alpha minus the tangent of beta, all divided by 1 plus their product, tangent of alpha times the tangent of beta. So what does that give us? The tangent of alpha. So alpha, that's going to be 5 over 12, adjacent over the, opposite over the adjacent. So 5 over 12 minus the tangent of beta. That's going to be the negative square root of 5 over 2 rad 5. Negative square root of 5 over 2 rad 5. All of this divided by 1 plus the product of these two. This actually simplifies to just be negative 1/2, right? Because the rad 5s are going to cancel. So we're going to get negative 1/2 in the numerator. So that's what this is equal to. So this whole thing is really just negative 1/2. So I can use that in my denominator here. So it's 1 plus 5 over 12 times negative 1/2. And let's simplify. So subtracting a negative is going to make this positive. So these are going to be adding. So 5/12 plus 1/2, we need a common denominator. So let's multiply by 6 in the numerator and denominator here. So 5/12 plus 6/12, that's 11/12 here, all over 1 minus 5 over 24. 5 over 24. In order to combine these in the denominator here, we need to get a common denominator, and 1 is just 24 over 24. So 24 over 24 minus 5 over 24, that's going to be, what is that? 19 over 24. So we have 19 over 24, and then in their numerator we have 11 over 12. So we are dividing fractions. So when you have a quotient of two fractions, we can take the numerator and multiply by the reciprocal of the denominator. So we get 11/12 times 24 over 19. We can do some reducing. 12 goes into 24 twice. So take this product, 11 times 2, that is 22. And then 1 times 19 is over 19. So the tangent of alpha minus beta is just 22 over 19.